Okay, sorry for that. Now you can hear me. Thank you. We have N, which is the total number of delegates. The delegates are 280. So we have A here. So if we are up to that point, the total here will get us to 280. And we are told 70 delegates represented Europe. So those who belong to Europe, according to our diagram, they are 70. And 70 is made up of C plus D plus E plus F. 96, they represented Africa. So 96 is B plus C plus F plus G. 128 is equal to, those who are in America, we have A plus B plus C plus D. 20 represented all the three. So 20 is C. 25 represented America and Africa. So 25 is America and Africa, that is B plus C. 22, they represented America and Europe, that is CD, C plus D. 26, they represented Europe and Africa. Europe and Africa, that is C plus F. That is C plus F. So having done that, now we can start the workings. We can start the workings. Start the workings. So we already have been given the value of C. So this one we mark it out and we come and record it here. Now that C, if we start down here, it will help us to know that F is what? If C is 20, F will be what? 6. Tukuja hapa. If C is 20, D will be what? 2. If C is 20, B will be what? 5. We go to now this equation. In this equation, we know B, C, D, this one. So we have A, which will be given as 128 minus 5 minus 20 minus 2. $109, $101. Then tukikuja kwa hii ingine, we know BCF. So we can be able to get G as 96 minus B5 minus C20 minus F6. At 165. So you're in this idea, and when we get there, we know CD and F. We know CD and we also know F. So that will help us get E as 70 minus CD, C is 20, D is 2, and F is 6. $42, so E is 42. Okay, so now that we do not know H, add all this, you subtract them from 280, that will give us H. $39. Okay, the next is now to answer the requirements. One, we have been told to do the Venn diagram. That is already done now. Roman 2, other solutions. So other solutions. Roman 2, it is saying the number of delegates who represented at least 2 continents. The number of delegates who represented at least 2 continents. So those who represented at least 2 are B, C, D, and F. Because when you are told at least 2, it means 2 or more. So that's why C is included. So B is 5, C is 20, D is 2, and F is 6. And F is 6. We have that 3. Roman 2, rather Roman 3 now. Roman 3 is the number of delegates who represented only 1 continent. So those who represented only 1 are A, E, G. So A is 101, E is 42, and G is 65. Those who represented only 1 continent, 203. That should be an 8 because of this 5. 208. Roman 4, the number of delegates who represented none. That is H. H is 39. Alright, so let's now handle part C of that question. Part C of that question. Part C of that question says, during the manufacture of a product, 0.002 of the product turns out to be defective. The product is supplied in packets of 10. A consignment of 100,000 packets is produced in a certain period. Using the Poisson distribution, calculate the approximate number of packets containing no defectives and so on. So the question is on Poisson probability distribution. Poisson probability distribution. Poisson probability distribution. When it comes to Poisson, I told you the beginning point is to write the formula. The probability of X capital being X small is given as E u raised power minus lambda. Lambda u raised power X, you divide by X factorial. Is that? Okay, so if that is true, we know that E is always 2.7182. E is always 2.7. So lambda is the mean. Lambda is the mean. So the mean here, we are told that the product, the 0.002 of the product turns out to be defective. Turns out to be defective. And they are supplied in packets of 10. Okay, so we are given the mean there is 0.002. That is the mean. Now, the next thing that we require is to know X. So Roman 1, when you are told no defectives, it means that X is 0. It means that X is 0. So probability that X is 0 will be equal to 2.7182. You multiply by minus 0.002 multiplied by 0.002 which is raised power 0, you divide by 0 factorial. So work out and send me the answer. Aha, 0.998. That's what Anna is giving me, 0.998. Okay, so if that is the case, the number of units. So the number of units or packets will then be 0.998 multiplied by 100,000. Let's multiply by 10 because I did not multiply here. Now that I'm talking of units, yeah, so that we make them to be units. So if you make them to be units, it will be 998,000. Yeah, 998,000. So you can either multiply here, this, or you multiply here. Yeah. Now, if you multiply here, it will be in terms of packets, which is what the examiner is asking. Or you can fail to multiply like I've done, and then gives us a now in terms of units. It's one and the same thing. The next one is Roman 2. Roman 2 is one defective. One defective. So that means X is 1. So probability that X is equal to 1 will be equal to 2.7182 raised power minus 0.002 multiplied by 0.002 raised power 1. You divide by 1 factorial. The same answer. Oh, so the whatever is too small, the difference is very small. Okay, so the units then should be 998 times 100,000 packets, which each contains 10 units. Roman 3 You are told two defectives. Two defectives. So that means x is 2. So probability that x is 2 is 2.7182 raised to power minus 002 times 0.002 raised to power 2 divided by 2 factorial. The other reason that could make it agree, rather be the same, you see now we're using 2.7182, which is already out there. But if you are to use E direct in the calc, there could be a small difference, but not a significant one. So, we are through, eh? Let's move to this other question of September 2021, question 5B. September 2021. September 2021, question 5B. Now the question says, a recent inspection of bolts produced by a certain company revealed that 40 bolts inspected. I think it should have been out of the 40 bolts inspected, 5 bolts are picked at random and inspected. Assuming that the distribution of defective bolts follows the Poisson distribution, calculate the probability that at least 3 bolts are defective. I think there is some missing information which should be reading, or the question should be, they inspected 40 bolts and 5 were found to be defective. 5 were found to be defective. That is how it should be. So when you are told to use Poisson probability distribution, Poisson probability distribution, I've said the first thing is to write the formula. And the formula is E raised to power minus lambda raised to power x divided by x factorial. And E again is 2.7182. So lambda, which is the mean, it is 5 out of 40. They found 5 in a total of 40. That's basically what the question says. They found 5 in a total of 40. So that is 0.125. So when you are told at least 3, it means that x is greater than or equal to 3. That means x is greater than or equal to 3, which specifically means there's a 3, 4, 5, all the way up to 40. Because there are 40 boats. Now that would be better solved as in probability of x greater than 3. It will be better solved as 1 minus probability that x is 0 or 1 or 2. Badala ya kusolve hizi zingine zote, you'll be better or it will be easier if you solve that way. So if that is true, then we will come here and say 1 minus 2.7182 raised to power minus 0.125 multiplied by 0.125 raised to power 0. You divide by 0 factorial plus 2.7182 raised to power minus 0.125 multiplied by 0.125 raised to power 1. You divide by 1 factorial plus 2.7182 raised to power minus 0.125 multiplied by 0.125 raised to power 2, divided by 2 factorial. So work out that and give me the answer. Waiting for the answer. Waiting for the answer. I think utajipanga na majibu baadaye because of the interest of time. Ndio. Leave it, utafanya baadaye. Making too long. Give you the answer. You know, today being our last lesson, I need to do some more questions. Part B inasema, assuming that the distribution is follows binomial. So, binomial probability distribution. Binomial probability distribution. Binomial probability distribution. Now with binomial, the formula is xx is equals to n combined x, p u raised power x, q u raised power n minus x. That is the formula. So you say let success to be defective. Tulisema, what you call success is what you are looking for. That is what you call success. So you are looking for those which are defective. So it then follows that P, the probability that you will be defective, it is the same thing that we had, it's the mean, which was 0.125. Remember, probability is given as desired over the possible. It follows that Q then should be 1 minus 0.125. 0.875. N is 40. And X, we are told, is at most. So it is less than or equal to 3. So this exactly means X is 0, 1, 2, 3. So you can tell us then probability that X is equals to 0. It will be 40 combined 0 multiplied by 0.125 raised power 0 multiplied by 0.875 multiplied by 40. Then probability that X is 1 it will be 40 combined 1 multiplied by 0.125 raised power 1 multiplied by 875 raised power 39. Raised power 39. Probability that x is equal to 2. It is the same thing. 40, you combine 2 multiplied by 0.125 raised power 2 multiplied by 0.875, you raised to power 38. And finally, probability that x is equal to 3. It is 40 combined 3 multiplied by 0.125 raised power 3 multiplied by 0.875 raised power 37. So work out, then you shall add the four of them and give me the answer down here. And try to be fast. Yeah, also as we take a break for prayers. So be back at 7. I hope you'll have finished so that we do something else. What is the answer? 0.2463? Something close to that? Good. So that is binomial. I think what I needed to remind you is the formula. So in case you patane nayo, you will not cry so much. You just rejoice and provide the answer. The next that I want to touch is this one of December 2017. December 2017. Question 2. December 2017. Question 2C. It is a normal probability distribution. Normal probability distribution. And it says that a survey conducted on citizens of a certain country to determine the annual capita income indicated that the annual income of the citizens is normally distributed with a mean of 980 and standard deviation of 160. One citizen was randomly selected from the country. Determine the probability that the annual income of the citizen is greater than 500,000. So Roman 1, greater than 500,000. So I told you to draw the table, but you can as well avoid it. Now here it is Z1. So Z1 will be X1 minus X bar. You divide by standard deviation. So X1 is 500,000 minus X bar. X bar is, the mean is what? 980,000. And the standard deviation is 160. Negative 3.00. So from the tables, probability that X is greater than or equal to 500,000. Now go to the table and read for me that 0.4987. And you remember I told you this value that you have read, it is the probability from this 500 to 980. So when they tell you greater than 500, we want those who are above 500, hata wale wamepita the mean, the other side. Yeah? So we will say plus 0.5, and that gives us 0.9987. I hope everyone is able to follow. If you are not, you should let me know. See, greater than 1220. So greater than 20,000. Z1 will be equal to X1 minus X bar. You divide by standard deviation. So this is 20,000 minus X bar, which is 980. You divide by 160,000. $1.50. So now from the tables, probability that X will be greater than or equal to 20,000. Now remember, what we shall get is the probability, what we shall get from the table is the probability kutoka 980 mpaka 1220, but we want the higher side. So then we will have to say 0.5 minus what we shall read from the tables. So go to the tables and read for me. 4330, 332, 332. Zero point one. Lazima kuwe na 8 somewhere. 0.0668. Yeah, good. Can see Wafura, even that. Roman 3. Rise between 852,000 and 1,100. So Z1 will be X1 minus X bar divided by standard deviation. So this will be 852,000 minus 980,000. You divide by 160. Negative 0.80. So our Z2 should be X2 minus X bar divided by standard deviation. So this is 11 minus 980,000. You divide by 160. Mm, 980,000. The mean. 0.31. 3, 8.
0.8125.
So we can make it 0.81. Divide this one. 0.75. So from the tables, probability that we are between 852,000 and 11 0.5615. You already have added. Yes. For these two, yes. So when you combine them, that is what they are getting. 2. Okay. The next one that I want to look at is this question of September 2021. September 2021, question 3B, Roman 2. The question is on hypothesis testing. Hypothesis testing. Nasema question what? Question 3B, yeah? 3B. Question 3B. Nasema Okay, now can you hear me? Good. Good. Sorry for that. So I am saying this question, you can either, first of all, the population is unknown. The population is unknown. It's a known population. A known population. And then you can see we have two samples. We have two samples. And the two samples, we have therefore to check the means difference. The means difference. The means difference. The means difference. So the first thing is to get the hypothesis. In the hypothesis, I told you that the null is given as x bar 1 is equal to x bar 2. That is, the first sample had a mean of 12,000. And the other sample had a mean of 13,000. That is how you state the null or the type. Then in the alternative, you say x bar 1 is less than x bar 2. That is 12,000 is less than 13,000. 12,000 is less than 13,000. So now, significance level. Significance level. Alpha is 0.05. Alpha is 0.05. Test statistic. Now here, when the population is unknown, we always use T. But there is also an alternative which comes in this way. Since n is greater than 30, when n is greater than 30, you can use Z. You can use Z, even when the population is unknown. But if n is less than 30, you cannot use n. Not unless, I mean, you cannot use Z, not unless the population is known. So because the other day, to me, T, either formula in a quantum level, we used it the other day. I want now to use Z, like the case of being known. So we will use, use Z instead of T. Let me clarify that. We use Z instead of T. I'm putting that so that you don't get confused. Now that the others, when we have said it is unknown, we have always used T. But I'm saying you can use T or you can use Z as long as the sample is greater than 30. But come on, less than 30, now it is unknown, you must always use T. So with that, then Z is given as x bar 1 minus x bar 2. You divide by standard deviation 1, which is divided by the root of sample size 1, plus standard deviation 2 divided by the root of sample size 2. Sample size 2. Sample size 2. All right. The next one is Z calculated. So Z calculated will then be 12,000 minus 13,000. You divide by the standard deviation. The standard deviation is 1,000 here. You divide it by the root of 40 plus 1,200. You divide by the root of 50. You divide by the root of 50. $324. Okay. I have 324. So the others, are we getting that? 324.769. Negative or positive? They should be negative. And it's too high. Wafura is giving me minus 3.05. Someone else? Yeah, so it's Annette is also giving me minus 3.05.
Yes.
Good, confirmed. So with that, now we proceed to decision rule. Decision rule. And this decision rule is one tail. So if it is one tail, we have, it's on the lower side. So somewhere here, this is minus Z critical. And this one I had told you to always know at 95, one tail is 1.65 when you're using Z. Kama ingekuwa two tail, it would be 1.96. So if you are here, you will say reject null. And if you are here, you will say accept null. You say accept null. So from there you make the conclusion. So what do we say in regard to conclusion? We reject null. We reject null since Z calculated is less than Z critical, that is minus 3.05 is less than minus 1.65. What does that mean? The meaning of that is tulikuwa tumeulizwa advise the management on whether there is a significant difference between the wages. So now that we have rejected null, which was saying they are equal, then we have to accept this, which is saying they are not. So then the conclusion is, or rather the meaning is that there is a significant difference. So uta copy from there. The way the question is just given. There is a significant, so we read namna hiyo. Venye tu ameandika kwa swali. There is a significant difference between the wages paid in Kisumu and Mombasa. So I think regarding hypothesis, that one we are good. Then from there, maybe we can attempt the one in part B of question 4 on the same paper. I don't know whether we solved it in class or not. So for hypothesis, I'm not able to do any other question. I suggest you look at what we did. And if you have forgotten, there is, I think there are some videos. If you go to my YouTube channel, you'll be able to see them for the hypothesis. I think the one that I taught the morning class, the whole of it is recorded and it is on the YouTube. So you can check and remind yourself about hypothesis. Even simplex, I also wanted to do simplex. But time cannot allow, and there are 2 videos on my YouTube on simplex. Again, one for the early morning class and another one I have taught Kitambo. You can see them. You get there, you'll be able to see them. So that now I was trying to run across the syllabus. So if that is the case, then I need to solve one question here. Regression. Time series. Vijana tuko tunafanya time series. Okay. But time series is not a difficult one. I'll be able to check. So let's try question 4B. Question 4B. Question 4B. So question 4B of the same paper inasema a group of 8 students were tested in a quantitative analysis and auditing examinations. The marks scored were as follows. Now you are told to compute the rank correlation coefficient. The rank correlation coefficient. So we have what we call the Spearman's rank correlation coefficient. So in that one, there is the student we have QA. Now QA, we have marks. Then we have rank, which I want to call RQ. Then we have auditing and assurance. We have marks and rank, which I want to call RA. Then I'm going to have someone known as difference in ranks squared. That is RQ minus RA. We square that, and that one is known as D. So we have A, B, C, D, E, F, G, H, and then we shall have the total. So this is 76, 43, 49, 84, 69, 69, 53, 36, 'So we can rank these ones. So the highest here is 84. So this is number 1. Imefuatwa na 76. That is number 2. Imefuatwa na 69, and there are 2 of them. So I told you when they tie, the first alternative is we are supposed to go to 3 and 4. So you add, and that gives us 3.5. So this is 3.5. This is 3.5. After that, we have this 53. Now this should be number 5. Then we have 49. That should be number 6. This should be number 7. And this should be number 8. We have 82, 57, 75, 86, 68, 92, 43, and 53. So the highest of all is 92. So this is number 1. Followed by 86, number 2. 83, 82, which is number 3. Followed by 75, number 4. Followed by 68, 5. Followed by 57, 6. This is number 7, and this is number 8. So we get the difference in ranks. 2 minus 3 square is 1. 7 minus 6 square is 1. 6 minus 4 square is what? 4. 1 minus 2 square is what? 1 minus 2 square is what? 3.5 minus 5 square is 2.25. 3.5 minus 1 square is 2.25. This other one square is what? 9. And this is what? 1. So add all those. So total is 6.25. Yeah. Oh, this one has a fanani is 6.25. Okay, good. 6.25. Because it's 2.5, 25. Okay, so add the total. $25.5. So the formula RS is given as 1 minus 6, sum of this square. You divide by n into brackets n square minus 1. So this becomes 1 minus 6 times 25.5. You divide this by 8, brackets 8 squared minus 1. After you have subtracted 0.6964. Good. So I think that is all what I intended to do, or what time can allow us to do. As I have said, there are 2 videos on Simplex. Make sure you access them. I think earlier on today I had sent another video for decision making. So I think if you look at that, you'll be good to go. Plus now you revise on time sinks. So I think from where I sit or where I start, we have done a good job. So kazi kwako, we will have a whole 1 week or more, slightly more. So go through your notes, read them, read again. You get stuck, you can always get me, either physically or online, and that would be good. Make sure you do not again stress yourself by wanting to know everything. You cannot know everything. You see, even now we have not been able to revise everything. It's only God who knows everything. So just do the much you can. Just do your best. But the best at least should enable you to get more than 50%. So don't say that I'm doing my best and you don't get to 50. So get at least 50 and even go all the way to getting an award. So we want to say thank you so much for being our students. We don't take it for granted that you chose us as your trainer. We wish you the very best. We hope to see you in the next semester, which we expect to begin on 15th of August. So thank you so much. God bless.